Hello, in this class we are going to learn the trigonometric identities. Let us consider a unit circle, the x-axis origin, this is the y-axis. Unit circle is a circle whose radius is 1 unit. Let me take a point P on this circle which is in the first quadrant. Both x and y are positive. Let us complete a right triangle. If I take this angle as theta, say, this is x and this is y. It's a unit circle, radius is 1 unit. We know that sine theta is y and cos theta is x by 1, which is x. Similarly, sine theta is y by 1, which is y. Now this point on the circle has coordinates 1, 0, and this point is on the y-axis and its coordinates are 0, 1, and this point is on the negative side of x-axis, so minus 1, 0, and this is on the negative side of y-axis, 0, minus 1. If theta is 0, sine 0, the point, if theta is 0, this point P comes and coincides with this point, 1, 0 point. So y coordinate is 0, 0 by 1. Y by 1 is sine theta, so sine 0 will be, y coordinate is 1 when theta is 0, therefore 0 by 1 is 0. Now cos 0, cos is x by 1, so here 1 by 1 it becomes. X coordinate is, when theta is 0, this is the line segment, so x coordinate becomes 1 here, 1 by 1, the answer is 1. Cos 0 value is 1. If theta is 90 degrees, 90 degrees is along this y-axis, 90 is pi by 2 radians. Sine 90. When theta becomes 90 degrees, the coordinates are 0, 1, x is 0, y is 1. So sine theta is y, 1 by 1. And cos 90 degrees will become, x coordinate is 0 here, 0 by 1, which is 0. And then 180 degrees. 180 degrees is on the negative side of x-axis, or I can say pi radians. If theta is equal to pi, sine pi is y by 1 is the formula. Y coordinate will become, for this point, y coordinate is 0. So 0 by 1. And cos pi is x coordinate, which is minus 1 by 1, minus 1. Then 270 degrees is along the negative direction of y-axis. 270 degrees is 3 pi by 2 radians. So if theta is 3 pi by 2, sine of 3 pi by 2. Sine value is y by 1. Y coordinate here is minus 1. And cos of 3 pi by 2 is, x coordinate is 0, so 0 by 1. Now see page number 57. I told you to memorize the table. You have studied these trigonometric ratios for the angles 30 degrees, 45 degrees, 60 degrees. Now we are going to learn for 0 degrees, 90 degrees, 180 degrees, 270 and 360 degrees. $30 degrees is pi by 6. 45 degrees is pi by 4. 60 degrees is pi by 3. 90 degrees is pi by 2. 180 degrees is pi radians. 270 is 3 pi by 2 radians. And 360 is 2 pi radians. Now sine 0 is 0. And sine 30 half, 1 by root 2, root 3 by 2. Sine 90 is 1. Sine pi is 0. This is minus 1 and 0. Sine doesn't have value on the x-axis. What do you mean by x-axis angles? X-axis angles are 0 degrees, 180 degrees, 360 degrees, etc. Or I can say 0, pi, 2 pi, 3 pi, 4 pi, all are x-axis angles. So on the x-axis, sine becomes 0. Now cos, you have to reverse it. Cos 0. Cos 0 is 1. And this is root 3 by 2. 1 by root 2. Half. Cos 90 is 0. Cos 180 is minus 1. And cos 270 is again 0. And this is plus 1. Cos doesn't have value on the y-axis. What are y-axis angles? 90 degrees. Y-axis angles are 90 degrees, 270 degrees, and keep adding 180. Or I can say pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, etc. So for all these angles, cos is 0. So cos doesn't have value on the y-axis. And then sine is positive for all these angles on the positive direction of y-axis, and in the negative direction of y-axis, sine takes minus 1 value. Similarly, cos takes plus 1 here, and cos takes minus 1 value on the negative side of x-axis. Now tan is going to be sine by cos. So tan is going to be 0 divided by 1, which is 0. And this is 1 by root 3, 1 root 3, 1 by 0 is not defined, 0 by minus 1 is 0, this is again not defined, and 0 by 1 is 0. And similarly you can write for cosecant, secant and cot, reciprocals of these three. Now we are going to derive the formula for cos of x plus y. Let us consider the right triangle. I will take this angle as x, and another right triangle I am drawing on top of this. This is 90 degrees, this is 90. Let me take this as y. And let this hypotenuse be 1 unit. A, B, C, D. Draw a perpendicular, E. And from here draw another perpendicular. Let this be F. You need not learn the proof, I am just explaining it. If this is x, this is going to be x. This angle is x. Alternate interior angles, and this is again x. Because sum of these two angles is 90, sum of these two is 90, therefore this must be equal to this. From triangle ACD, in this triangle ACD, this is sine y. Because sine y is opposite side by the hypotenuse. Hypotenuse is 1, so DC length will be sine y. And this is cos y, AC length. because cos y from that pink right triangle is adjacent side by the hypotenuse. Hypotenuse is 1, so AC length becomes cos y. And then I am going to find cos of x plus y in triangle AED. Cos of x plus y is, cos is adjacent side by the hypotenuse. Hypotenuse is 1 there in AED triangle. Now AE can be written as AB minus EB. Now AB length is, see cos x from ABC triangle. In triangle ABC, in this triangle, cos x is adjacent side by the hypotenuse. So AB gives you cos x into cos y. If you cross multiply, you get AB here. Cos x into cos y minus, now EB I have to calculate. EB is equal to FC. EB length and FC length are equal. From that small triangle DFC, in that triangle let us find sin x. Sin x is opposite side by hypotenuse. Cross multiply, you get FC length, sin x into sin y. So FC and EB are same, sin x into sin y. So that's how we get the formula cos of x plus y is equal to cos x cos y minus sin x into sin y. Similarly, we can find from this sin of x plus y also. Now I'll tell you how to remember this formula. Sin of x plus y. So from the same figure you can derive this formula also. Sin of x plus y is sin x into cos y plus cos x into sin y. And cos of x plus y just now we derived, I am writing it again, which is cos x cos y minus sin x sin y. Now sin of x minus y, sin x cos y minus cos x sin y. Cos of x minus y is equal to cos x cos y plus sin x sin y. Memorize these 4 formulae and easy to memorize. See, sin is a good function and cos is a bad function. Remember it like that. So what it does is sin of x plus y. For sin of x plus y, sin takes the first one and gives the next one to cos. Plus sign is in between, so plus in between here. And next time, for the next term, sin takes y and gives x to cos. It is a good function. Once it takes the other function, it gives it to the other cos. And then cos of x plus y. Cos is a bad function, very greedy it is, remember it like that. It takes both for itself, cos x, cos y. And then next time only it gives to sin x, sin y. And because it is giving to sin, it doesn't like that. So it gives a negative sign also. Remember it like that. So cos of x plus y becomes cos x cos y minus sin x sin y. And then sin is again a good function. So x it takes and gives y to cos. And there is a minus sign in between. So in between minus sign here. And then it takes y, then gives x to cos. whereas cos is not a good function. It takes both x and y for itself and then it gives it to sine, but when it gives it to sine, it changes the sign and gives. So minus will become plus here. Now it will be easy for you to memorize these 4 formulae. Now using this, we can derive tan of x plus y. Now tan of x plus y is sine of x plus y by cos of x plus y. Sin x plus y, we know the formula, sin x cos y plus cos x sin y. Since it is a good function, sine is a good function, it takes one variable and gives the other variable to cos. But cos is a very bad one. It takes both for itself, changes its sign and then gives it to sine. Now divide both numerator and denominator by cos x cos y. Divide by cos x into cos y, so that we get 1 in this position. So by dividing we get cos y will get cancelled, sine by cos is tan x, this term becomes tan x, and here cos x gets cancelled, sine by cos y will become tan y, divided by this is 1, minus sine x by cos x is tan x, and sine y by cos y becomes tan y. This is tan of x plus y formula. So we have next 4 formulae. Just now we derived tan of x plus y, which is tan x plus tan y, divided by 1 minus tan x tan y. Derivation is not important, you memorize the formulae. I am deriving it so that it will be easy for you to memorize. And similarly, we can derive the formula for this, which becomes tan x minus tan y divided by 1 plus tan x into tan y. Now next, cot of x plus y formula, cos of x plus y by sine of x plus y. Again divide to get 1 in this position. Here 1, you will get this as the formula, cot y plus cot x. And then cot of x minus y formula, it is cot x cot y plus 1 divided by cot y minus cot x. Next you have to memorize these 4 formulae. Now we will derive 2 angle formulae. That is sine 2x. Sine 2x can be written as sine of x plus x, and use sine x plus y formula. It becomes sine x cos x plus cos x sin x, which becomes 2 times, same terms, 2 sin x cos x. So sine 2x formula is, I will write the direct formula now. So sine of 2x becomes 2 sin x cos x. And we have another formula in terms of tan for sine, which is 2 tan x divided by 1 plus tan square x. It can be derived from this formula. See, sine 2x, just now I showed you, it is 2 sin x cos x. I can write the denominator as 1. We are replacing that 1 by the identity cos square x plus sin square x. Now let us get 1 here. I have to divide by cos square x. If I divide by cos square x, one cos term will get cancelled. Sin x by cos x gives you tan x. This becomes 1, and sin square by cos square gives you 1 plus tan square. That's how we get this 2 tan x by 1 plus tan square x formula for sin 2x. Same way, we can derive two-angle formula for cos 2x, which is cos square x minus sin square x. We can derive this using that cos of x plus y formula. And then you can replace cos square by 1 minus sin square. So it becomes 1 minus sin square, which is 1 minus 2 sin square x. Or you can replace this sin square by 1 minus cos square identity. In that case, you will get 1 minus sin square x minus 1. And then same way, we can write the denominator as cos square plus sin square and divide by cos square. You will get in terms of tan, which is 1 minus tan square x divided by 1 plus tan square x. So cos 2x has 4 formulae. So according to the answer which we need, we can select any one of these 4. Similarly, using tan x plus y formula, we can derive the formula for tan 2x, which is 2 tan x divided by 1 minus tan square x. These are the formulae, two-angle formulae. So you have to memorize all these two-angle formulae, sin 2x, cos 2x and tan 2x formulae. Then let us derive three-angle formulae. Sin 3x. I can write sin 3x as 2x plus x and then use sin x plus y formula. We get sin x cos y, that is cos x here, plus cos 2x into sin x. Now I can write formula for sin 2x, which is 2 sin x cos x, and into cos x will give you cos square, and cos 2x also I am changing it in terms of sin. I have 4 formulae, no? I am going to use this in terms of sin. 1 minus 2 sin square x into sin x. Now again change this also in terms of sin. Cos square can be replaced by the identity 1 minus sin square. Now open the brackets. Everything I changed it in terms of sin. Open the brackets and simplify. We get 3 sin x minus 4 sin cube x. Okay, this is how we derive the formula. Derivations are not important. I am just showing it so that it will be easy for you to memorize. So sin 3x formula is 3 sin x minus 4 sin cube x. Same way, we can derive the formula for cos 3x, which is 4 cos cube x minus 3 cos x. And tan 3x formula, 3 tan x minus tan cube x divided by 1 minus 3 tan square x. These are the three-angle formulae. Then the next one is sum to product formula. Cos x plus cos y, sum of these two. Cos x minus cos y, sin x plus sin y, sin x minus sin y. Now you have addition. or subtraction in between these terms, it will become product. It changes to multiplication. You will have 2 here, and here you will get x plus y by 2 and x minus y by 2. Okay, now cos and cos. Cos is a back function, so it takes cos here, both it takes, because it is plus. Now there is a minus sign in between. Okay, so it gives both to sign, but with a negative sign here. Because of the negative sign, it doesn't like, it gives both to sign, but it puts a negative sign in front. And then sine is a good function. So one it takes, the first one it takes, and the second one it gives it to cos. And here this has a negative sign. So first it gives this to cos, and then the next function is x minus y by 2 is for sine. See, on the right hand side you have product of these terms. So that's why sum to product formulae. And then same way we can change product to sum. To cos x cos y. Let us put the minus sign here. Minus 2 sin x sin y. 2 sin x cos y and 2 cos x sin y. It's just the reverse of the above 4 formulae. So here we will get x plus y and the second one x minus y. X plus y and x minus y. Now 2 cos x cos y, both are cos, so here also both are cos with plus sign in between. And here both are sign, that has a negative sign, therefore cos of x plus y with negative sign cos of x minus y. Now one is sine, one is cos, so it is going to be a sine function. Sine only gives like that, right? It takes one, it gives the other one to cos, right? So this will be sine of x plus y and plus, because sine comes first, no? So sine of x minus y, whereas here cos is first. Therefore sine of x plus y and minus sine of x minus y. These two are reverse. These 4 formulae, just you reverse the previous 4 formulae, you get them. You have to be thorough with these formulae. In 3-4 chapters we use trigonometry in 11th standard. In 12th, 7 to 8 chapters are there where we use trigonometry. Without the formulae you cannot do the questions of the next 2 exercises. Please memorize these formulae and be thorough with them. Okay, next we are going to learn few more formulae. X-axis, Y-axis. We know ASTC rule. All are positive in the first quadrant. S, T, C. In the second quadrant, sine and cosecant are positive. In the third quadrant, tan and cot are positive. In the fourth quadrant, cos and secant are positive. Now, if I take the fourth quadrant angle, negative angle, it will be in the fourth quadrant. For example, my theta lies between 0 and 90, say, and theta is negative. I will take it as x. So the angle is in the fourth quadrant. It is less than 90 minus x. This will be in the fourth quadrant. Now in the fourth quadrant, sine of minus x is the fourth quadrant angle. In the fourth quadrant, sine is negative, so it will be equal to minus sine x. And cos of minus x, cos in the fourth quadrant is positive, so it becomes plus cos x. And tan is again negative, so minus tan x it becomes. Now cosecant is the reciprocal of sine, so cosecant of minus x is equal to minus cosecant x. And secant of minus x, secant is positive in the fourth quadrant, so it becomes plus secant x. And then cot of minus x, cot is negative in the fourth quadrant, so minus cot x. Now next set of formulae you have studied in lower classes already in 10th standard. X-axis, y-axis, 90, this is pi by 2, 90 degrees. If I take the angle pi by 2 minus theta, pi by 2 minus theta is less than 90 degrees, so it will be in the first quadrant. This pi by 2 minus theta is a first quadrant angle. So in the first quadrant, sine, all are positive, all trigonometric ratios are positive, so it becomes cos theta. And we change the ratio. Sine will become cos, cos will become sine. Cos pi by 2 minus theta becomes sine theta. And tan pi by 2 minus theta becomes cot theta. And cosecant pi by 2 minus theta, first quadrant, we have, since it is pi by 2, we change the ratio. Cosecant will become secant theta. And secant pi by 2 minus theta will become cosecant theta. And cot pi by 2 minus theta becomes tan theta. All answers are positive because pi by 2 minus theta, that is 90 minus theta, is in the first quadrant. That's why all trigonometric ratios are positive. But remember, if it is pi by 2 minus theta or 90 minus theta, we have to change the ratio. Now next formula. Let us take the angle pi by 2 plus theta, where theta lies between 0 and 90. If I add an angle between 0 and 90 to pi by 2, it will be lesser than 180. It will be a second quadrant angle. This pi by 2 plus theta is in the second quadrant. Because it is pi by 2 here, we will change the ratio. Sine is positive in the second quadrant. Only sine and cosecant are positive. Other trigonometric ratios will become negative. When you decide the sine, you have to see this ratio, sine of the second quadrant angle. So put the sign accordingly. And then cos of pi by 2 plus theta. Pi by 2 plus theta is a second quadrant angle, and cos in the second quadrant is negative. And because we have pi by 2, we change the ratio. And then tan pi by 2 plus theta. Pi by 2 plus theta is a second quadrant angle. Tan in the second quadrant is negative. Minus, because of pi by 2 here, we change the ratio. It becomes minus cot theta. And then cosecant pi by 2 plus theta. Pi by 2 plus theta second quadrant angle. Cosecant in the second quadrant is positive. Because we have pi by 2 plus, we change the ratio. It becomes secant theta. Secant pi by 2 plus theta. Again, pi by 2 plus theta is the second quadrant angle. Secant will be negative. Because of pi by 2 plus, we change the ratio. Pi by 2 plus theta is the second quadrant angle. Cot is negative. Because of pi by 2 plus, we change the ratio. It becomes minus tan theta. Next. Pi is this. If I take the angle pi minus theta lesser than pi will be a second quadrant angle. In the second quadrant, we know that sine and cosec are positive, other trigonometric ratios are negative. Pi by 2 plus theta is also second, that is more than pi by 90. That is also second quadrant angle. Pi minus theta is also second quadrant angle. But for pi, we don't change the ratio. If it is pi here, we don't change the ratio. Sine will be sine, cos will be cos, tan will be tan, etc. So this will be sine theta. Cosecant is also positive in the second quadrant, and because of pi, we don't change the ratio. It is cosecant theta. Then cos pi minus theta. Pi minus theta is the second quadrant angle. Cos in the second quadrant is negative. Because of pi, we don't change the ratio. It is minus cos theta. And then tan pi minus theta. Pi minus theta second quadrant angle. Tan is negative. Because of pi, we don't change the ratio. Secant pi minus theta is second quadrant angle. Secant is negative. Because of pi, don't change the ratio. The answer will be minus secant theta. Then cot. Pi minus theta is the second quadrant angle. In the second quadrant, cot is negative. And for pi, we don't change the ratio. Next set of formulae. Pi is here. We are going to write the formulae for pi plus theta. That is more than 180. More than 180 will be a third quadrant angle. In the third quadrant, tan and cot are positive, other trigonometric ratios are negative, and because you have pi here, we don't change the ratio. Only for pi by 2, 3 pi by 2 we change. For pi by 2 and 3 pi by 2 we change the ratio. For pi and 2 pi we don't change the ratio. Pi plus theta is in the third quadrant. Sine in the third quadrant is negative. Because of pi we don't change the ratio. Pi plus theta. Cos is negative. Don't change the ratio. Cos will be cos. Tan in the third quadrant positive. Tan theta. Cosec in the third quadrant negative. Because of pi we don't change the ratio. Secant in the third quadrant negative. Don't change the ratio because of pi. Cot in the third quadrant is positive. Because of pi we don't change the ratio. Cot will give you cot itself. Now this angle here is 3 pi by 2. 3 pi by 2 minus theta. If I subtract an angle from 3 pi by 2, it will be in the third quadrant. In the third quadrant, tan and cot are positive, other trigonometric ratios are negative. Pi plus theta is also third quadrant angle. 3 pi by 2 minus theta is also third quadrant angle. But for 3 pi by 2, we change the ratio. Sine will become cos, cos will become sine. Tan and cot. Similarly, cosec will become sec, sec will become cosec. For pi, we don't change. Okay. So, sine 3 pi by 2 minus theta is a third quadrant angle. Sine is negative. Because of 3 pi by 2, we change the ratio. It gives you minus cos theta. Cos in the third quadrant is negative. Change the ratio because of 3 pi by 2. Tan in the third quadrant is positive. And we have to change the ratio. So it will become cot theta. Cosecant 3 pi by 2 minus theta. In the third quadrant, cosecant is negative. We change the ratio because of 3 pi by 2. Secant in the third quadrant is negative. Change the ratio. And here cot of 3 pi by 2 minus theta. It is positive and you have to change the ratio because of 3 pi by 2. Now next we will write for 3 pi by 2 plus theta. 3 pi by 2 plus theta will be a fourth quadrant angle. In the fourth quadrant, cos and secant are positive. Other trigonometric ratios are negative. And for 3 pi by 2, we change the ratio. Sine 3 pi by 2 plus theta. Fourth quadrant, change the ratio. Sine is negative in the fourth quadrant. Change the ratio. It becomes cos theta. In the fourth quadrant, cos is positive and change the ratio. Tan in the fourth quadrant is negative. For 3 pi by 2, change the ratio. In the fourth quadrant, cosecant is negative. Change the ratio because of 3 pi by 2. And secant. Secant is positive. 3 pi by 2, you have to change the ratio. It is cosecant theta. And then cot of 3 pi by 2 plus theta will give you fourth quadrant, cot is negative. Therefore, it becomes minus, change the ratio, minus tan theta. Then we will write for 2 pi minus. 2 pi and 0 positions are same. So 2 pi minus theta will be in the fourth quadrant. In the fourth quadrant, cos and secant are positive. And remember, for 2 pi, we don't change the ratio. Sine of 2 pi minus theta. 2 pi minus theta, fourth quadrant, sine is negative. We don't change the ratio. Sine will be sine itself. Cos in the fourth quadrant is positive. so it becomes cos theta. Tan in the fourth quadrant is negative, minus tan theta. Cosecant in the fourth quadrant is negative. We don't change the ratio, so it becomes minus cosecant theta. And secant 2 pi minus theta, fourth quadrant secant is positive, and don't change the ratio, secant theta. Cot in the fourth quadrant is negative, don't change the ratio, minus cot theta. Next, we will write for 2 pi plus theta. 2 pi is here. 2 pi plus theta will be in the first quadrant. In the first quadrant, all trigonometric ratios are positive. For 2 pi, we don't change the ratio. Sine will be sine, cos will be cos, etc. 2 pi plus theta will be sine theta, because theta and 2 pi plus theta will take up the same position. Cos of 2 pi plus theta is cos theta, all are positive. And tan 2 pi plus theta is tan theta. Cosecant 2 pi plus theta is cosecant theta. Secant 2 pi plus theta is equal to secant theta, and cot 2 pi plus theta is cot theta. Memorize all these formulae. Without memorizing the formulae, you cannot do the exercise. Please learn and be thorough with all these formulae. Bye-bye.